Welcome to Advanced Data Analysis 1 with me, Erik Erhardt, Professor of Statistics at the University of New Mexico. In this video, we'll continue the Class 7 assignment on plotting bivariate relationships when we have a numeric response. So we'll scroll down to the timetable and scroll down to Class 7. And there is no our markdown file here. That means that the assignment must be a continuation from our outline. So we'll go over to RStudio. I have already opened the assignment where we left off, renaming or creating new variables. And here is the rubric for today's assignment. In fact, before we get started, let me save this document as a new name. I'm recording this on the next day. And we'll knit it to make sure that we are starting with a document that compiles. Pretty sure I clicked that. Let me try it again. Okay, looks like my computer is hesitating. All right, in the meantime, we will read the rubric. We've got I see. All right, let's just open this in the browser and we'll jump down to Class 07, plotting bivariate relationships. Okay. So we've got a scatter plot to make and a box plot to make, and there are places to put each of those. For each, we're going to plot y is going to be a numeric variable, and for the scatter plot, x will be numeric. We have to label the axes and put a title on there and interpret the plot. And for the box plot, the only difference is now we have a categorical variable as the x-axis, where it's useful for comparing, say, the mean and the distribution for each category. We'll use, very soon in the semester, we'll use scatter plots for understanding relationships between two numeric variables, and then we will fit a regression line to the data to understand the trend between x and y. And for an analysis of variance, we'll use box plots to ask whether the means are different from each other between categories. All right, so let's get started. When we don't know what to do next, typically the idea is to go back to the website. I'm going to scroll up above the timetable to the model assignment. You can start with the one that I'm creating here, or you can go to a previous year's for the details there. I pressed Control and clicked on the HTML to open it in a new tab, and we'll find the plotting. Well, if I just type bivariate, hey, there we go. And these first two are scatter plot and box plots. Perfect. So I'll jump down to there, and let's scroll through the plots, and then we'll come back and look at the code. So the first plot we're going to look at is the scatter plot, where we have two numeric variables. And I'm going to sort of ignore the comments here for the moment. And here is one of the most boring scatter plots you'll ever see. And that's because we're looking at how does the total cigarettes smoked depend on a person's age when that age goes from 18 to 25. And it turns out, at least in the NESARC dataset, that for young adults, their total cigarette smokes that does not change over that range of years. Now, in previous years, I restricted the data to just that narrow range of ages, but this year I'm not doing that restriction. So I'm hoping that we'll see a different trend when we extend this out to people who are in their 60s, 70s, and 80s. If people who qualified to participate in the NESARC dataset live that long. It seems that they have a lot of competing risks. So the aspects of this plot, we've got a point for every person. You can see that the points are not solid dark, and that's because I made each point a little bit transparent by adjusting its opacity, right? If something's opaque, you can't see it. So opacity is the degree of to say it the other way, is how transparent it is, or how opaque it is, how hard it is for light to go through. And if you make this if you reduce the opacity, then you can see through the point, and you can see that the points get darker when there's multiple points in the same position. And that's a way to help us see the density of the points. There's clearly many more points down here near 0 than there are up above 1,000. Okay. There's also a blue trend line. This is a regression line, I think. I'd have to go look at the code exactly. It's a LM, means linear model, and in this case that linear model is just a straight line. Now linear model in statistics does not necessarily mean a straight line, though many of the linear models we fit are straight lines. It has a slightly different definition, but we'll dig into in advanced data analysis too. All right, we can improve this plot in many ways. In particular, all these points are laying on top of each other. And so if we were to spread them out a little bit, and I think that's what I do next, then we get a better sense of the data density here. In particular, there's lots of these points right here at, somewhere around 600 or so. That's probably like, people who are smoking 1 pack a day or something. And maybe this dark line is people who are smoking half a pack a day. We're also seeing, or at least to my eye, what I'm seeing is there are more people sort of in their early 20s than 18 and 19-year-olds, just based on the density of points. It's not very striking finding. But by spreading them out, this is called jittering the points, by sort of adjusting their horizontal placement, we can we keep the points from laying on top of each other quite as much, and we can see where the data density is higher. To show you a beautiful example, because height and weight are so well related, as a person is taller along the x-axis, okay, so 60 inches is 5 feet. This is the person's weight on the vertical axis. And the regression line here is sort of representing the average, so that for a person who is 60 inches tall, we expect them to be about 125 pounds. Okay, for a person who's let's do 72 inches, which would be 6 feet. That person, 180 or something. And one thing that I can see here is that the density of points is darker on the low end, and then it sort of has this right skewness. In terms of the weight axis, we have right skewness. We have outliers on the high end, and so that would be on the right side. If you tip your monitor onto its right side, you'll see the right skewness. And that's because there are basically few people who are quite a bit heavier than it's easier to get heavier than it is to get skinnier, right? There's sort of a lower bound on how light you can be, but that upper bound doesn't exist quite as easily. Let's see if there's another thing that we can do is we can create facets to show how the differences depend on, in this case, on a categorical variable. In this case, we're looking at sex. And so because we understand that height and weight is genetically determined by our sex chromosomes, that at least for humans, men tend to be larger than women. And you can see that in the distribution, right? So for height, it looks like the center is somewhere around 65 or so, whereas for men, the height's somewhere around maybe 71 inches. And there may also be looks like there's a slight vertical displacement as well, though it's a bit harder to see in this plot. Okay, so that's going to be the first set of plots. Let's also quickly skim through the ANOVA plot below, and then we'll come back and look carefully at the code. For box plots, we now have a categorical X variable. So let's see what example we have. So we've got total cigarettes smoked. I think that's the same variable I was looking at before. Let me do a quick page up. Total cigarettes smoked, yes. And the categorical variable on the x-axis is depression, whether someone is not depressed versus yes depressed. So there's a lot of layers on this plot, right? So the grammar of graphics, ggplot, is a layered grammar. So you sort of specify the axes, and then you specify what geometric objects you're going to put on there, and then you can add additional things on top, on top, on top. So what we have here is we've got, I think, maybe a box plot on the bottom, which is this white box. It's a box and whiskers plot, right? So the middle horizontal line here is the median. The lower bound is the first quartile, Q1. The upper bound is Q3 for total cigarettes smoked. And then the whiskers go out either to a maximum value or minimum value, or it stops based on some criterion. And typically the criterion is like 1.5. It will go out 1.5 times the interquartile range, which is the difference between Q3 at the top and Q1 at the bottom. So you look at that range. This whisker will go out as far as that, and then anything beyond that is sort of defined as an outlier. So we've got the box on there. We've plotted all the points on top, and I've also put a red diamond for the mean. And there's lots of symbols you can use. The reason I use a red diamond, well, the red part's not important except that it stands out, but the diamond part is because then you've got these corners of the diamond to indicate exactly the value of the mean. If you were to put a square, you'd have to try to figure out what the middle of that square is, which is visually a little harder. Same thing with a circle. So I use a diamond, so it's easier to see actually where on the axis the middle falls. Let's see, based on this plot, my monitor's not at a great angle for me to see it, but it looks like no depression maybe is slightly lower than yes depression, but it's hard to tell. They look at roughly the same to me. You can see that also I've jittered those points left and right. All right, so let's go back and look at the code that created each of these plots, and then we'll implement this for ourselves. So it looks like my research question here, I don't have a meaningful question to ask. Okay, so I guess I just picked a couple. So let's start with this code here. And why don't I do this in RStudio? Because then I'll be able to show the iterative nature of this. So I've opened up, the assignment. I'm at that rubric, and I'm going to maximize this window and scroll down to the scatter plot. Recall Control-Alt-I inserts a code chunk, just as you can do code insert chunk. And I'm going to paste in this code here. Now I'm going to work right here in the editor. I'm not going to just knit it and see what happens. So the first thing I need to do is set the working directory, session working directory to source file location. That sets the working directory to where I've got my files. And then I need to run all the code above this code chunk, all the way down to here. So I'm going to click on that, and those code chunks are going to run here in the console. Oh, it got ahead of me. Doing lots of things, creating plots and stuff. All right, all done. So now we've got all the data loaded. You can see it up in the upper right-hand corner under the environment. These are all the objects that we need. It's basically just the nisarc_sub. Okay. Yes, that's it for now. All right. So I want this window to be sort of, the plot window to be big enough that we can see what's going on. It's a little tough. I'm recording this just in HD, which is sort of a small screen size by today's standards, so that you can hopefully easily see this if you're watching it on your phone or something. But it does put some constraints on me for recording videos. All right, let's do a couple things. So first thing, we're going to do a ggplot with the nisarc_sub data Then we're going to assign the aesthetics of age to x. So age is going to be on the horizontal axis, and total cigarettes smoked is going to be on the y-axis. Now, when you choose these relationships, we often try to think of them in a causal way, that x causes y, even though the statistical models that we'll learn in these 2 semesters of advanced data analysis do not allow us to draw causal inferences. Okay, we can only really talk about things, how variables associate to each other, how they're related. We can't. There are ways of doing causal statistics. That's beyond our scope right now. So, with that in mind, we tend to think of how does x influence y. Okay, so you want to choose which axis based on that relationship. Okay, so I'm thinking of how does age affect the total cigarettes smoked. Okay, I think that's a more sensible question than how does the number of cigarettes smoked determine your age? Though certainly the more cigarettes you smoke, you will quote unquote age faster, right? All right, so we first assign those axes. I'm going to put the cursor on that line, press Control Enter to submit that line down into the console. Then I'm going to plot the points, geom point. We do Control Enter. And then, so all this information is in P. If I want to see it, I need to print it. You can print it by doing print P, which I think helps make the plot actually appear when you knit it. Of course, if you just do P and press Enter in the console like I'm going to, it does interpret that object and create the plot. I'll do that right now. I'll press Enter. And it is plotting about 43,000 points. Okay, it gives us a warning message that 297 of these rows had missing values, and so we don't have points for those people. All right, so there is a plot. One thing you can do if you want to see more detail is if you click zoom, it pops out a window just for that plot. Okay. And to my eye so far, I don't really see much of a relationship between age and total cigarettes smoked. Now we can do a couple things to help us see through here. The one challenge we have, of course, is that there's lots of points lying on top of each other. We don't really have a sense of what the multiplicity is. So for any given point, how many data points actually fall right there? I have no idea. So stat smooth, let's see, I think stat smooth is one way to put a regression line over the data. So I'm going to add to this plot by pressing Control P right here and then printing it again, and we'll create the same plot, but now we're going to overlay a regression line. Place your bets on positive slope or negative slope, or it will just be horizontal. My computer's fans are blowing. Oh, there's a slight increase. That's what I was expecting. Yeah, almost no slope, but a slight increase. So as you get older, you tend to smoke a little bit more. And in fact, you can see the people who are most extreme, all this stuff, this is like people who are roughly 30 and up. And then it drops off probably because a person's lungs can't handle it by the time they get above 75 years old or 80 years old. All right. So that's most of this assignment. That would be we're almost at a sufficient plot. We need to do some labeling. Let's do a couple more things to this. So I'm going to create a different smoother. I believe it's geom smooth with no arguments. I think that, so I'm going to start this again to reset the plot. I think that puts in what's called a lowest smoother. A lowest smoother is a locally something weighted. Local regression. Here we go. Locally weighted scatter plot smoothing. Wait, do those letters even make sense? Okay, this is the sort of locally estimated scatter plot smoothing. And what it does is it allows the curve to, it allows the line to sort of follow the trend of the data, right? In recent times, we're used to seeing COVID-19 deaths per day or cases per day, and we're getting a 7-day weighted moving average. That's a type of smoother. It's taking the last 7 days, taking the average number and plotting that point and plotting that point over time. So now we see that there's an increase that peaks around 65 years old or so, and then it decreases again as people get up to 98 years old. So that maybe in some ways is a better fit to this data than a straight line, because we get this downward relationship for older people. All right. That being said, I sort of like that curve. I'm going to leave that there. In this class, we're not going to do inference based on a lowest smoother, but it gives us some sense of how sensible a regression line is. So maybe one thing you could do is you could do color equals red for the straight line regression. And I'm using British spelling because ggplot was written by Hadley Wickham, who came from New Zealand, and they use British spelling. You can do English or American spelling if you like, and that's just fine. All right, let's do a couple more things. Let's label our plot. We've got a title. All right, maybe one way to lay this out is we've got an x-axis, we've got a y-axis, and there are other options we can put in here. We could put in a caption. You know what? I'm going to put in a caption just to show you. I love caption. All right, so let's put in a few things. So this is a person's age. It's actually the same as the variable name. So I'm not going to relabel X because it's already a person's age and there's no real misunderstanding about that. Y is total cigarettes smoked per month. Okay, so the only real piece of detail that's being added here is the per month. And the caption, I don't know, I think maybe I just put it sort of placeholder. A caption can be used to, I know what we can do. We can do the blue line is the lowest smoother, red line is linear regression, simple linear regression. Okay, and we can say key. All right, let's take a look at that. So we'll reset that, print everything. Well, you know what? It's because we have so many data points, right? Geom Smooth makes a choice depending on how many data points you have. We actually are not using a lowest smoother because it sort of takes an impossible amount of time once you get a very large data set. Notice that there is a warning message here that it's using a generalized additive model. So I'm just going to put in GAM smoother. Okay, so let's zoom in on this and take a look at what we've got. All right, do we love our plot? Well, the data aren't very interesting. I hope you'll have chosen more interesting data, but we've got a title up here, total cigarettes smoked versus age. We've got age on the x-axis, we've got total cigarettes smoked per month on the y-axis, and in the bottom right we have a key. Blue line is, and I just updated that, it will say GAM smoother, comma, red line is a simple linear regression. Great. I like to use a smoother like this to give, if I'm fitting a very simple model like this, I like to use a a smoother because it helps me determine whether my red regression line is fitting the data as well as I want it to. Now, there will be other diagnostics to determine that, but it's at least a very quick visual check of saying, okay, well, for people who are old, my red regression line is overestimating the average number, perhaps. But it does pretty well, basically from 18 up to about 75 or 80 years old. It's only in the people who are older than 80 that where it starts to really have substantial bias. All right, I'm pretty happy with this plot. Hope you are too. So let's go back to the rubric and see if we've got everything. Scatter plot, label the axis, and title, interpret the plot. Okay, so let's interpret the relationships here. You can put your interpretation either above or below. I think in my example, I did close that window. It's just being slow. There it is. I put the interpretation above. I don't think I like that interpretation. Okay. Great. Oh, you know what? Something we didn't experiment with? We didn't really experiment with alpha. So alpha is the opacity. It's how many points need to lay on top of each other in order for light to not pass through. Right? So imagine you've got like a bunch of pieces of stained glass, and you start stacking them on top of each other, and eventually light is going to have a really hard time getting through all those stacks. And I usually represent it as a fraction because this says that I need 4 points before it turns completely black. So what if I make that 1/10? Then I'll need 10 points before it's completely black. And we'll have quite a different experience of this plot with alpha equals 1/10, because lots of points will be very light, and we'll start to see the data, the more dense data show up. So look at how light these points are up in the fringes. So it's really now focusing our attention on where there's lots of data points. You know, it might even help to add a little bit of jitter to these. Okay, so we can add some jitter. There are several ways of doing that, and let me show you how I get basically all my help. I do r space ggplot. Now I want to do geom point, and I want to do jitter, and that will probably be enough. I only want to jitter horizontally, and I think, here we go. Geom point position equals jitter. Let's take a look there. And I think that there's a way to jitter just x. So position, so geom jitter is the function name. Okay. Position is the argument that allows me to jitter. But let's go down and take a look at the arguments. Position. Okay. Well, they're not giving us enough details. Perhaps when we get down to the examples, we'll get the additional details that I want. There is a way to do jitter just horizontally. Okay, width and height. Okay, we're getting close. Here we go. Okay, so instead of geom point, if you want to jitter the points, we're going to replace that with geom jitter. That is what I have in my second example that we scrolled through. So let's go replace my geom point. So one strategy here is, I know geom point works. So let's not delete that line. Let's just comment it out. And then it will be around for later if we need it. I'm going to use geom jitter. Okay, I did that the long way. Now, do I want to jitter the width or the height? So in this case, I think I just want to jitter, well, I don't know, some of these points, maybe I want to jitter both the width and the height. I believe the width and the height are relative to the actual scales. Okay, so width equal a half would allow points to jitter to the half to the left and a half to the right of each integer age, and then a height of I don't know if height really helps us very much, but why don't we do a height of 10? It will sort of distort things that are at 0, but let's give it a try and see what we get. And is my zoom window here? Okay, so things are a little bit cloudier now, aren't they? That little bit of jitter helped sort of spread out a couple of these horizontal bands. I'm not sure if I'm really getting that much more information now than I was before or not. Maybe I've jittered a little too much up and down, or maybe a little bit too much horizontally. But the point is that you can play with this a little bit and find if you're having trouble with points laying on top of each other, jittering is a way to help see behind it without distorting the data too much, right? Keep in mind that we're only distorting how the data is visualized. We're not changing any of the actual data values. Oops. Interesting. I'm trying to change to that zoom window, and it is not showing up. Oh, here we go. Okay, so I've reduced the jitter a little bit so that we're seeing gaps between the age years. I don't know, something like that maybe is okay. It does help sort of provide some density information down in these lower bands. I don't know. This data is not a fantastic example of that. You know, a better place where it's going to show up is for the height and weight example. So I'm scrolling down to the height and weight example. If I were to add a bit of horizontal jitter here, we're going to start to see a better cloud of data. So I think it would be more satisfying in this height and weight. Why don't we just very quickly do it just to see? Okay. I still have to come back and interpret that plot. So I'm going to grab my jitter. Okay, and I recognize I'm going pretty fast. I'm going to jitter my weight by, say, 0.5, or that was a height in inches. Let's do that. I'm not going to jitter my weight. We'll just jitter my height by 0.5 and take a look at height and weight. Still working? There we go. Ooh, all right, so there we start to see a real cloud, right? It's 43,000 points is a lot. And they were definitely being obscured here. To my eye, this looks like maybe there's only a couple hundred points. But when you spread them out, you really get a sense of how many points there are. Okay, so I really like this plot better than the other one. Why don't I just leave here an example of height and weight. All right, let's go back to the interpretation here of the previous plot. So what features do we want to show? We want to say something about the spread, maybe in each direction, and how closely they resemble a straight line. So I would say, the relationship between age and total cigarettes smoked is very weakly positive, but does not resemble a straight line relation. Total cigarettes smoked is right skewed, which results in many extreme values above the regression line. Okay, so we're not going to worry too much about the regression line. We just see that the red line has a slight positive increase. Positive relationships go up, negative relationships go down. No relationship would be horizontal. This is basically horizontal. And we'll be able to test whether it's horizontal or not a little bit later in the semester. So I think this is a fine interpretation. All right, so that is the scatter plot. Let's move on to the next. All right, a box plot. By the way, you might, I'm paging up, you might try a few sets of variables here before you decide on the one that you love. And want to keep. That's sort of what I mean. All right, let's go over and grab some code for the box plot. I'm going to page down. Oh, and I'll say also that if you happen to have a categorical variable that you want to look at, like how does this relationship depend on sex or by ethnicity or some other category, whether or not you're depressed, you're welcome to create this facet. So I have, you'll recall in, I think what I call chapter 0, or maybe it's chapter 1, a bunch of R code stuff. There are several examples about facets, and this facet wrap, you put a tilde, and then the categorical variable you want to have a plot for each level of that categorical variable, and just add that as a layer and wait, and so then it just breaks it up. It creates a plot window for female, by male, and etc. for each of the categories. All right, so let's take a look at the box plot. I'm just going to start by copying this code and pasting it here. And now I'll start thinking about what variables I want to use. I'm going to clear the plot window down here. Not really important, but the broom, let me say two things. The X, the white box with the red X, will delete just the current plot. And the broom will delete all the plots. So if you want to sort of clear your history there, it can be helpful. Looks like okay. So in this case, I've got depression, which is a categorical variable, and total cigarettes smoked is numeric. I'll start with this plot, but I may end up at the end of this trying another couple examples. So first thing, so let's simplify this right now. Let's just create a box plot, and I'm going to put a comment in front of the rest of the lines here, and I'll run this chunk of code. All right, so here's a beginning plot. Boy, total cigarettes smoked is so right skewed that it's a bit annoying to work with. The zero value is for the is the minimum. the first quartile and the median, because more than half the people don't smoke. It's just a subset of them that do smoke. I wonder if we should change this data a little bit. Let's consider this. So the data that we're using, NESARC _sub, we can create a filter and subset, say, just the people who smoke. Okay, so we can basically say, like, among people who smoke, who either don't have depression or do have depression, how does their smoking change? In fact, there may be a slightly better variable to use. By the way, maybe if you've followed along this far and done your scatter plot, maybe knit your document before moving on to this box plot, just to make sure your document's still working. All right, so let me take a detour. 1060 is my row number. I'm going to scroll up and take a look at my code book and see if there's which variables I have to distinguish the total cigarettes smoked. I can certainly do if it's greater than 0. That's probably the easiest. I'll just stay here and do that. So I'm going to start with NESARC sub, and then that's my pipe. Then I'm going to filter where total cigarettes smoked is greater than 0. Okay? So that whole section now, that is the data that will be used to plot. And this type of code for plotting, I use this quite regularly. Sometimes I create a new data set, but if I just want to look at one aspect of the data, this is a very quick way to do it. So I'm only going to plot this for the people who have at least one cigarette smoked. So I ran that now. Here's my new plot, and honestly, I love this way better. Okay, so it doesn't really make sense to think about the total cigarettes smoked for people who don't smoke. All right, guys, I'm going to use the same thing above in my scatter plot. Okay, so I'm going to go back in time for a second, and I'm going to paste this up here. So among the relationship, let's see, comma, among people who smoke, comma, let's see. Let's run this again, the scatterplot matrix. We're going to see a very different relationship potentially because we no longer have any zeros. Well, that line is definitely higher up, which makes sense because all the zeros at the bottom that were pulling it down are no longer there. So the regression lines have moved up. But we are sort of still seeing the same pattern. But I think I like this better. All right, I'm gonna keep that up here. Okay, and all I have to do is put in a little clause here that says among people who smoke. All right, let's go back down and continue with our box plot. All right, let's run this again. There's our box plot. Looks like the median is about, I don't know, 300 for that group and maybe 450 for the yes depression group. So it looks like there's some differences there. We can add some points if we want on top of there. Right now I have alpha equals 1/4. That's far too low for plotting. I don't know, it's not 43,000 anymore because we filtered it, and we know that fewer than half the people smoke. So, but it's going to be somewhere like 10 or 15,000 people. So let's make these points fairly light. I'm going to do one. We'll need 100 points in order for it to be completely opaque. Now sort of show a bit of a cloud where the points are. Okay, another thing that shows up is the no depression is much darker than the yes depression. So we have more people in the no depression group. Okay, that looks pretty good. Notice that I am using geom jitter, and the width is 0.1. That's 0.1 along the horizontal axis. I'm not jittering the vertical axis at all. Though we could do that. Height equals 1, maybe. All right, let's do the next thing. The next piece of code, highlighting that doesn't really do anything, puts a diamond at the mean for each group. Looks like that height jitter didn't really improve anything. Let's just leave it as it was. So let's put a diamond at the mean. Okay. If we make this a little wider. All right, so one way to put a diamond at the mean is to use the function stat summary. The summary it's going to create is it's going to calculate a function based on the y variable, and the function it's using is the mean. All right, you could put the median in here, you could put a specific quantile, like the 80th quantile or the 5th quantile. You could put in lots of different functions, but we're going to calculate the mean. The geometric object it's going to create is a point. The shape number is 18. So let's go take a look at that. R plot shape. Okay, and if we just look at images, we're going to find one of these examples. Is there one that's much better than the other? This one looks a little better. Cookbook-R is a website that I go to. So if you want an open square, that's plot number 0. Plot symbol number 0. A circle is 1, etc. Ones in here that I use regularly are the diamond. Let's see, which one did I use over here? 18. Okay, so 18 is this diamond up here. I use the solid circle, number 20. Sometimes I like to use a plus sign. I guess those are the main ones that I use. I don't love triangles because you don't have a good sense of what the vertical center is because the corners are at the bottom. But for distinguishing groups, triangles tend to be pretty good. Okay, so I just wanted to show you where you could find those symbols. So shape 18, size 6. So a size, I think the default size is something a little bit less than 1, because anytime I do size equals 1, the points seem to get bigger. Size 6 is going to be quite big. The color is red, and alpha equals 0.8 allows the symbol to have a little bit of opacity so that you can still see that there are points below the symbol for the mean. All right, let's make this a little bigger. All right, you can see, well, it might be hard to see, but there's a little bit of gray behind that red diamond. This looks pretty good. Something else that I sometimes add to these plots, I don't know, I don't want to get too much in the weeds. That's a pretty good place to end that. Last thing we want to do is to create some labels. So we've got our title, we've got X, we've got Y, and that's plenty. All right, so X is whether or not they have depression, and Y is total cigarettes smoked. I've already typed some of this before. Oh, my title here is actually giving a conclusion, right? Depression does not predict total cigarettes smoked. I'm not sure that's true when we've got all age range people in there, right? My previous conclusion was based only on people aged 18 to 25. And when we restrict it to people who smoke at least one cigarette, we have a very different relationship. So maybe we have total cigarettes smoked by depression. Okay, so I'm sort of putting my y-axis by x-axis variables in that order. So we've got sort of depression status, and then we've got, I like sort of like what I did before, so I'm going to scroll up and grab my y up here, so I don't have to type it again. Okay, total cigarettes smoked per month, and we might as well put a caption in here that says, data, let's see, or filtered to include only smokers. So cig greater than 0. Cigarettes greater than 0. And I'm going to add that caption to my previous plot as well. And it will give me, I can't do caption. It will give me a way to show you one more thing. /n. /n means new line. Okay. All right, so we're going to go back in time just for a second and recreate this plot up here. And we're just going to look at the caption down below. So if my caption has the key, blue line is the smoother, red line is the simple linear regression, and then /n. /n, anything that follows a backslash is a special character. So for example, a /t is a tab character, /n is a new line, and there's other characters that you can represent using a backslash. And you can see down in the bottom right, we have a new line that says filter to include only smokers. Okay? And maybe I'll put a period in there, and I'll grab this for my plot below, which I don't need because I already typed it from there. Okay, so let's look at our box plot now and see if we're happy. The things that we just did were labeling the axes, the title, and putting in the caption. This looks pretty good to me for a first pass at a plot. All right, so let's do some interpretation. Okay. Maybe the first thing I see is that the total cigarettes smoked per month. Okay, so maybe a sort of a summary first. I'll tell you that writing is not my strength in life, so I need a moment to gather a thought. I guess I'll start by just interpreting the mean. For NESARC participants who smoke, okay, so the number of cigs greater than 0. Those who are depressed have a slightly higher mean. That's the red diamond. Oh, that's something we can put in our caption, right? That the red diamond equals the mean. So red diamond is the mean. Okay? And then we can do a /n to create a new line. All right, so let's rerun this piece of code, update our plot. Nice. Now we've got red diamond is the mean. All right, restarting over. For NESARC participants who smoke, cigarettes greater than 0, those who are depressed have a slightly higher mean, red diamond, than those, or a slightly higher mean number of cigarettes per month than those who are not depressed. Cigarettes smoked per month is right skewed, so there are many people who smoke very little, but few people who smoke a lot. That's pretty good. Maybe one more comment just to say something. So right, when we interpret a distribution, we talk about the location, the center, spread, skewness, and outliers. There's maybe one more comment we could make is, let's see, because of the right skewness. So total cigarettes smoked per month is right skewed. So there are many people who smoke very little, but few who smoke a lot, which increases the mean beyond the median. Right, so those extreme values in this upper tail are pulling on that mean. The mean is sensitive to those, and the mean gets pulled out, whereas the median is resistant to these outliers. And that's a fine interpretation. All right, so all I'm sort of doing is describing the relative position of the means between the groups. You might have multiple groups, right? So you don't necessarily need to compare every pair of groups, but you might say where the you might discuss the group that has the highest mean, the group that has the lowest mean, and if there's any sort of general trend in the intermediate groups. Later in the semester, in about a month, we'll be doing hypothesis testing, and we'll be able to ask the question, are these two means statistically different from each other or not? Okay, but right now we're just sort of providing a description of what we observe. And I think that's everything for this video. I apologize. I seem to be creating long videos, but it's hard for me to think back and think of very much I could cut out while giving you the detail you need to make good decisions for your own projects. All right, so I hope you have some great plots. I look forward to seeing them. In the next video, we will cover plotting the categorical responses.